I'm Anil Kumar, and to complete our understanding of how to sketch a polynomial function, here is an example of odd degree function. Nonic polynomial, degree is 9. Polynomial given to us is 4 minus x times 3 minus 2x square minus 1 minus x cube minus x cube. 3 plus 3, 6, 7, 8 and 1, 9, right? So whenever you want to sketch a polynomial, what do you look for? Let's list those things, right? There are four major things which we should consider. Okay, now what are these things? First thing is degree, right? So we should know what is the degree. It is very easy to find degree. Just count the exponents. 1 plus 2 is 3, 3 plus 3 is 6, 6 plus 3 9. So degree is 9 for us. Second is leading coefficient. So I'm writing an as our leading coefficient. Now leading coefficient is all these x's when multiplied will give you leading coefficient. We don't really have to expand it, right? We don't have to factor into anything, but just take care of these x's. So the first one is minus x, a linear factor. The second one is a quadratic factor, minus 2x squared. And then we again have a linear factor minus x, cubic. And then we have another cubic factor. Now, so these are when multiplied lead to the leading coefficient. So what does that give us? So let me write down the value. We are actually interested in the sign. So we have negative, negative, so two negatives. This one will turn out to be positive and that one is third negative. So three negatives will give us a negative. We know leading coefficient is negative. Actually, this much is enough. But sometimes you are interested in finding the value of leading coefficient. Let's find it out. So 1 times 2 square is 4, correct? And so the other terms are 1 and 1, so we get minus 4. That is, minus 4 is your leading coefficient, right? And of course x to the power of 9, that gives you the first term. But in this case, important thing is leading coefficient is negative, correct? Then the next thing to look for is the zeros and their multiplicity. So let me write down multiplicity separately. And one more thing which we have to look for is y-intercept. Okay, so these are the things which we have to look for. You can pause the video, write your answers, and then check with mine. Okay, so let's look into zeros now. So zeros for us are, let's begin from left to right. Here we have 0 when x is 4, right? So this term will be 0 when x is 4. 4 minus 4 is 0. So first 0 is when x equals to 4, for example. The second one, this will be 0 when x is 3 over 2, right? 3 over 2. So let me write 1.5, 3 over 2. Then this one will be at 1. So next is, and then we have it at 0. Now these are our zeros. Let's write down their multiplicity also. For the first one, it is linear, so no need to write, but we'll write 1. 1.5, the second one is of degree 2, or multiplicity 2. Then these are of 3, correct? So these are our zeros. Now we should look into y-intercept. Y-intercept means if x is 0, what is the value of polynomial? So value of polynomial will be 0 in this particular case. So that gives us all the information required to sketch a polynomial function. So let us now sketch it. Let me use the space to sketch. So we have zeros at all positive values, okay, except for zeros, fine, that's good enough. So let me just draw a line here. I think I can use space this side. Okay, so I'm taking advantage of all positive values for zeros, right? Okay, so all positive, that's good, except for 1 which is at 0. So we can place our zeros, 0, and then we have at 1, 1.1 and 5 and 4. So, okay, so let this be 1 and then, well, this is 2, so 1.5 will be very close, and then let us say this is 4. Okay, so these are our zeros. Now we have placed the zeros there, but now let's begin to sketch the function. So sketching starts with the leading coefficient. This normally is our first point. Negative leading coefficient means right side down. So right side is down for us. That means right down. That is right side down. Second thing which we have to look into is degree. Odd degree, right? That means opposite ends. So this will kind of go like this, right? So that implies opposite ends. So right side down, opposite ends. Okay. Then let's look into zeros and multiplicities. Then we have to do zeros, and fourth is multiplicity. We have already marked our zeros. Multiplicity. The one at origin is of multiplicity 3. So here it will kind of turn like this and go. X-axis has to be horizontal tangent for this at this point. That is kind of very critical. Okay. Now we have one at 1. 1 is also cubic, so that also kind of will turn like this. That is again cubic. 1.5 is the third one, so which is parabola, which will bounce back, and then we have a linear 0 at 4, correct? So that is the shape. Now what we need to do is we need to connect these points carefully with a smooth curve. See how I'm doing it, right? So we can do it like this, and we can say, well, go like that. Not that vertical, but still. Okay. And then we have to connect these points somehow. Okay, that's fine. And we go like this. So that is the function which we have drawn. And let's label all the zeros. So we get 0, 1, okay, 1.5 and 4. Do you get it? And this is the x-axis, and that is our polynomial p of x. And that's how we do it. I hope the steps are absolutely clear. Go through them once again and then draw it. We could have actually stretched it a bit to get a neat and clean graph, but I was kind of lesser space with me, so I did it. But as far as you are concerned, you could have more space, and you could have had it more stretched horizontally to give a better look. But otherwise, I think you understand the concepts and the steps involved, right? So you should actually start with the leading coefficient, then degree, zeros, multiplicity, and the y-intercept at the end, right? So y-intercept, right? So these are the steps to draw any polynomial for that matter. So we have clearly given you instructions, and I hope that should help you in your test. Thank you and all the best.